Hello, this is Unit 5. We're about halfway through the year. This is 5.1, using models to add fractions. So we're going to take some fractions and add them together. I find this a useful skill to know how to do, especially when I'm building things in construction type things, projects at home, or baking. This is something that's important to know how to do. So here we have a hexagon. It's a shape that's just to kind of learn how this works. And it has 6 corners and 6 sides. So that means it's a hexagon. Now, if we wanted, we could break this up into certain pieces and have a fraction of them. So if I chop this in half, so I'm going to draw a dotted line across here, there would be 2 halves, right? How many pieces do I have? I have 2 pieces. And let's say we're just talking about one of those pieces, it would be 1/2. Notice 2 halves make a whole. So right here, this red trapezoid represents half of this. It's this bottom half here would be 1/2 of this shape. So 1/2 of a hexagon would be the shape. If I got 2 of them, this top of the fraction would be 2 pieces of those 2 total pieces that this one whole thing was chopped up into. Now, I could draw this a different way. I could draw it as a rhombus. So if I take this middle section and every second one I chop it up into that, every second corner I draw a line to, I can make 3 shapes, 3 of these rhombuses. There's this one here, and then there's 2 other ones. 1, 2, 3 pieces makes the bottom of my fraction, and I'm talking about one of those pieces is 1/3 of this fraction. I could chop it further up into more pieces, like so, and have 1, 2, 3, 4, 5, 6 equal sized pieces. Remember, they're equal sizes, 6 of them. And so one of those 6 pieces could look like this one at the bottom, and that would be a 1/6. So this triangle is 1/6 of this rhombus is 1/3, and this trapezoid is 1/2 of this yellow. Now I'm going to go back. I've drawn a dotted line across here. Notice this trapezoid, it's 1/2, but it's also, if I chop it up into more pieces, it would be 1, 2, 3/3. So 1/2 would be equal to 3/6. 3/6 be 1, 2, 3 of those sixths. So 3 of these triangles, you put them together, you could actually make one of these. So 1/2 is the same as 3/6. And look at the relation here. 2 times 3 is 6, and 1 times 3 is 3. So equivalent fractions will always be able to multiply the numerator and the denominator by the same number to get an equivalent fraction. If I look here at this rhombus, so I'm going to erase this other part, this rhombus right here, you notice that it is the same size as 2 of these triangles. We could take one of them here and one of here. So this rhombus, as far as sixths go, it would be 2/6, because 3 times 2 is 6, 1 times 2 is 2. So here's an example of adding fractions. It says here Zach and Ronnie each bought a small pizza. So they each had a pizza. There was one and another one. Zach ate 3/4 of his pizza and Ronnie ate 7/8 of his pizza. How much pizza did Zach and Ronnie eat together? So we're going to put it together. That signifies that we're going to add. We're going to add this 3/4 and this 7/8 that each of those people ate. So 3/4 plus, because it says to eat together, 7/8, which is what Ronnie ate. So 3/4 plus 7/8. There's some ways we can show this pictorially. If we draw 3/4 of a pizza, we'd have 1, 2, 3 pieces of a pizza that's cut into 4, and we'd have 7/8. So this pizza instead is cut into 8 equal pieces. We would have 7 of those pieces. So if we think about it, notice that 2 of these pieces here is the same amount of a pizza as this 1/4. And right here, we're missing 1/4. So if we want to figure out all together, we could figure out that 2 of these could be moved over here and fill this and make one whole pizza. So 2 of those blue pieces leave and move over, and it's one whole pizza. And what's left? There's 5/8 left here. 1, 2, 3, 4, 5. Because 2 of them have gone over here. And to add this up, 3/4 plus 7/8, it will be one whole pizza plus 1, 2, 3, 4, 5 5/8 of the pizza. So together, Zach and Ronnie ate 5/8 of a pizza. 1 5/8 pizzas, I meant to say. For these questions that we'll do on this assignment, there are a lot of different ways to do them and show them with the pictures. One would be to draw this. This is how I often think. But you could also do it using some math, as I showed before. So I'll do 1A here. From this, it says to use pattern blocks or fraction circles, model each picture, then find each sum. So here's the model. We're going to find the sum from this. Looking here, what fraction is this? There's 2 pieces, so that's our numerator, our top. Out of 1, 2, 3, 4, there's 4 pieces. And we're going to add it to this picture here, which there's 2 pieces in total, and we're talking about one of those 2. 1 is what's shaded. That's the one we're talking about. Out of 2 pieces, so that's our numerator. So this is 2/4 plus 1/2. Now, if we think about it, this 1/2 is the same thing as 2/4. And notice this space right here would be able to fit these 2 in it. So if we think about it, 1/2 is the same thing as 2/4, right? It'd be 1, 2 out of something cut into 4 equal pieces. So this is the same thing as 2/4 plus 2/4, which is the same thing as 4/4, because 2 plus 2 is 4. And 4/4, 4 pieces, if we drew it all together, we'd have our 2/4 right here, and we'd have our 1/2 here, which makes up one whole thing, pie, pizza, whatever we want to imagine that is, circle graph. So it would be 1. 2A says to use a model to show each sum, sketch the model, and write an addition equation for each picture. So we need that equation. So the first one is 7/8 plus 1/2. That's what it tells us. So let's draw a picture. When it's an even number, I often draw square type things. I use the squares in my notebook, but you can also do circles. I'm going to do circles this time because that's what we've been doing. But remember, the picture doesn't have to be the same shapes as long as the pieces of the whole are the same size. These aren't perfect, but they're pretty close. So we're talking about 1, 2, 3, 4, 5, 6, 7 pieces of this 8-piece pie, let's say. And then we're also talking about 1/2 of it. So we're going to add those together, 1/2 plus 7/8. Now, if we think about it, this 1/2 could be broken up, right, into 8ths, right, by splitting those quarters into halves. So we have 1, 2, 3, 4. This is the same thing as 4/8. So 7/8 plus 4/8 would be 7 plus 4 is 11/8. That's what we're talking about. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11/8 of these, and we put them together, it's 11/8. Now, if we think about it, one of these pieces, this piece right here, could move over there, and we'd have one whole pizza plus 1, 2, 3/8, which is 1 3/8 as a mixed fraction. Sorry, I went off the bottom of the page there. 11/8, it's the same thing as one whole pizza and that. I'm going to draw the picture on the side because it said to show the model the whole way through. We'd show this, that it's one whole pizza. And what's left over here, when we turn that in here, is just 1, 2, 3. Only 3 of those. That's 1 plus 3/8. And we're left with 1 3/8 as our answer. 4A IV, so this is the fourth one there. It says 1/6 plus 3/6. We need to add this. So when you're adding with the same denominator, so the same bottom of the fraction, you keep that, and then you just add the tops. 1 plus 3 is 4, so it's 4/6. Now, something we didn't have to do in our previous examples was simplify the fraction, because 3 1/8 can't divide by the same number. They're not divisible by any same number except 1. We'd need to just leave that as is. Whereas 4/6, we could simplify this, and I'm going to draw a picture to show this on the side. We can divide these by 2. 4 times 2 is 2, and 6 divided by 2 is 3. I think I said times up here. I meant divided by. So it's actually 2/3. Now let's look at this. If we have something, I'm going to go with a chocolate bar kind of thing. I'm going to break it up into 6 pieces. We've got 1/6 of a chocolate bar plus 3/6 of a chocolate bar. Okay. Let's take that one piece and let's move it in right here. So we wouldn't have any of this chocolate bar anymore because maybe we ate some of this, and then there's one piece moving over, and we'd have these 1, 2, 3 still here and 1 filled in. We'd have 4 pieces, right? 4/6. That makes sense? Okay. But if we look at this, it's actually the same size, same pieces as if we hadn't chopped it here. It would be 2 pieces out of how many? 1, 2, 3 pieces. So that's why it's 2/3. Sorry. If we chop that same size chocolate bar, the same size, into 3 pieces instead, the same amount of space would be 2 of them, 2/3. So that's how we got 2/3 there.